Welcome to Smartman Academy. Okay, for today we'll be doing chemistry. That's basic calculations in chemistry. That's the topic. Now, for the basic calculations in chemistry, that is isotopy. There's calculations under it. We'll be doing oxidation number. Then we'll be doing empirical formula, empirical and molecular formula. Two of them goes along. Then empirical and molecular formula. Then we'll be doing percentage. But before we reach any points, percentage calculations. Now, before we go any further, I ask, what is mass number, right? What is mass number? See, let me explain. This is an atom. This is an atom X. I usually say the mass number is A. The atomic number is Z. Remember, the mass number is the number of the proton plus the neutron together. Then the atomic number is the number of proton. Then the neutron now will be C. If mass number is equal to proton plus neutron, so that's mass number. So A is equals to mass number, Z is equals to atomic number. So if A is equal to mass number, which is proton plus neutron, then for you to get your neutron, what will you do? You do mass number minus proton number to give you your neutron. You understand? So you can just say your neutron is the number of mass. Okay, neutron number is the proton number subtracted from the mass number. That's the neutron you get. You understand? Proton number can also be called atomic number. So if this element is sodium, let's use a typical element. If this element is sodium, the mass number will be what? Let's start from the atomic number. The atomic number will be what? The atomic number is 11. The mass number will be what? See how I usually do it, though. See how I usually do it. I usually do 11 times 2. I usually multiply it by 2. In some cases it works, in some cases it not work. 11 times 2 will be 22. It's close, but the mass number is what? 23. You get? So if the mass number is 23, the atomic number is 11. What is the neutron number? Neutron number is equals to mass number, which is 23 minus 11, right? It says 12. Thank you. That's how you just calculate your mass number and your neutron number. Understood? Right. You need to write. The foundation of what you should know is that mass number, atomic number, proton number, and neutron number. Just know those terms. Then furthermore, we'll be doing who discovered the stuffs and the rest. Okay, now we're going to isotope. That is isotopy. Now, what is isotope? What is isotopy? What is that? This is oxygen. This is oxygen. This is how isotopy happens. This is oxygen. This is oxygen. Oxygen is 8. That is number 8 in the what? Periodic table. So the atomicity there is atomic number is 8. Then the mass number will be first this in oxygen is 16, 17, 18. So from this, can you define isotopy? From this, define isotopy. This is the phenomenon where an element exhibits has the same atomic number but different mass number. You get? So isotopy is basically the phenomenon where an element has the same atomic number. Oxygen here is 888, but different mass number 16, 17, 18. As I was saying, that's why I did this stuff at first. A and Z. That is, you know that this A is the atomic number. Anyone up is the atomic number. Down one is what? Thank you very much. So the same words, atomic number 888, different words, mass number. That is isotopy. You get? But that is the phenomenon is isotopy. But these stuff are isotopes of oxygen. You get? These stuff are isotopes of oxygen. That's just it. That's for isotopy. Think. Hold on. The knowledge of isotopy helps us to know. I think I told you the mass number. I told you the mass number for sodium. I told you the mass number of sodium is 23, right? Now, we cannot know the exact mass number of oxygen because of this isotopy. Because it has isotope. Isotope. So we can say from here, where's that stuff? We cannot know the actual isotope, actual mass number of this stuff. So what we do is, like when you titrate something, you take the first titer, second titer, third titer, you now do average, right? You get. Now that's what we're going to do here. But what we're doing here is just like you take this one, take this one, take this one. We now take the relative atomic mass. Relative atomic mass. The atomic mass that is related to this one, related to this one, related to this one. So you kind of do something like this plus this plus this will give you relative atomic mass. You can also call it relative molecular mass. You get me? Relative atomic mass or relative molecular mass. You understand? That's just it. That's for isotope. Because from the question here, they'll ask you what is the relative molecular mass of an atom, of an element that has two isotopes, that has three isotopes. That's what we want to solve now. You understand? Let's go. The question here is saying the relative the relative atomic mass of a natural occurring lithium consisting 90% 7. Which one is 2 now? Okay. Then 10%. Now, these are the two isotopes of lithium. So lithium will not have a mass number that is just straightforward. It will have a relative atomic mass, not a straightforward mass number. You get me? So to solve this, to get the relative atomic mass, this is how we solve. Whenever I hear what they call this percentage, just do 90/100. Understand? Times, what is the difference between this one and this one? Is this 3 and this 3? I mean, what is the difference between this lithium and this lithium? Is this 7 and this 6? So times 7. We are finding is the relative atomic mass or the relative molecular mass. Plus, this one is 10/100 times 6. You understand? You understand? Cherry, do you understand? So what we are looking for is what? The relative atomic mass of this compound lithium. You get? So let's solve. You can do like this. It should be 0.9 times 7 plus 0.1 times 6. For the first one is what? 6.3 plus the second one is what? 0.6. All of them is equal to what? We can say therefore the relative atomic mass of lithium, just like you are adding the two and finding the average, something like that. Just have that mentality. Then we will now do it as that is 6.9. So that's the answer. So let's check our option. The first option is saying A 7.1, B 6.2, C 6.8, D 6.9. So you are correct. Question right. A silicon containing ore. A silicon containing ore has 92% silicon. Is it 92? Yes, 92% silicon. But the mass number of this silicon is 28. Then it has 5% another silicon. But this silicon now, the mass number is 21. Then it has the last one, that is and 3% silicon, which this one is mass number 30. Now they said calculate the relative atomic mass of this silicon. Calculate the relative atomic mass of this silicon. First of all, we have 92% of silicon 28, we have 5% of silicon 29, and we have 3% of silicon 30. So you say calculate the what? Relative atomic mass. So you can say relative atomic mass, that's what we're looking for. Relative atomic mass is not. We are literally looking for the relative atomic mass of what? Silicon. Having all these other isotopes. Please pay attention, pay attention. I need your maximum attention now. Just pay attention. Say 92 what percent, that is 92 over 100. Are you getting me? Of what? Of silicon 28. Follow. Plus 5 what? Percent of what? Silicon 29. Follow. Plus what? 3% of what? Silicon 30. This is all you need to do. Now you take it bit by bit. Bit by bit, what will you get here first? What did you get here? 25.76 plus 1.45 plus 0.9. Everything gave you what? 28.11. So the relative atomic mass of silicon 1, silicon 8, 28, 29, and 30 all together is 28.11. You get? An element has two isotopes. Two isotopes. The first isotope is looking like this, 2010, and the second isotope is looking like this, and 2210. And is represented with a ratio of 1:3. What is the, and is represented in the ratio of 1:3. What is the relative atomic mass of X? You get? They say this, is it 1:3? Yes. Therefore, this one is 1:3. You get me? Now they say what is the relative atomic mass of element X? Very simple, but just take down the notes first. Just take down the notes. Now, first thing you should know is this one belongs to what? This one, it belongs to element X of 20, mass 20. It belongs to element X of mass what? 22. Let's go now. So we have element 20, 10, element 22, still 10. 1:3. So the first thing you will do in ratio, when you're solving ratio, this one belongs to what? 20. So when you're solving this question, just as if 90% belongs to so and so. So this one belongs to what? 20 plus the 3 belongs to what? 22. Are you getting me? Now, because of it is ratio, you add the two of them together. All over what? If you solve this, that's your answer. Can you solve and give me your answer? Solve and give me your answer. This is 20 log 66 over 4. This is 86 over 4 is what? 21.5. This is your relative atomic mass of compound X because of it. Right. Chlorine consisting of two isotopes. Chlorine consisting of two isotopes of mass number 35 and 37. 35 and 37 in the ratio of 3:1 has an atomic mass of 35.5. Has an atomic mass of 35.5. Calculate the relative abundance of the isotope of mass 37. This is the last one for isotopy. You understand why I chose this one? They said chlorine. So they said chlorine has the what? Has mass numbers of 35 and what? 35 and 37. Now, listen, this question is very unique. You know why this question is very unique? They gave you the relative atomic mass to be what? 35.5. 35.5. They also gave you 3:1, Abi. 3:1, the ratio of 3:1. Now, listen. They gave you this one. They gave you this one. Now, use your common sense. They want you to know the percentage of this one. Okay, just like let's say you are mixing, you want to take tea. The end product of the stuff is tea. You want to take. You add your chocolate, you add your milk. Let's say you don't take with sugars. Let's say you add chocolate, you add your milk. So they want you to get the percentage of 37, right? The milk you use to form the sugar, to form the tea. You get? So you are getting the percentage of 1. You get? So that let's just go ahead. You understand? You understand better when I percentage of 1, which is 37. 3:1, but we are finding the percentage of just this one. So we do 1, which is for 37, over the ratio is what? 3:1. You add the two ratios together, it will give you 4. Now, because we're doing percentage, we times by 100. This is percentage for what? 37, mass number of 37. Now let's add percentage of 35. It will be 3/4 times 100. Find this one, give me your answer. Find this one. This one is additional now. Give me your answer. All of them should be total to 100. You understand? What did this one give you? 25. So the relative abundance of this one is 35 to 25. So the next one will be what? 75. That's why this question is unique. It has ratio. They gave you 1. They gave you 1 to find. Then they gave you the stuff, the relative atomic mass already. You understand?